Okay, so we're going to go ahead. If you have AutoCAD open, just go ahead and open up a new drawing file. Okay. And so we're going to take a look at the P-line command. Everybody still hear me all right?
Yes.
Okay, great. All right, so the P-line command is over in the Home tab of the Draw section. The P-line right next to the line. P-line stands for polyline. And so what it is it's a command that will allow you to draw lines connected. So if we look at what's going on here with a normal line command, if you're drawing a line and then a line and a line, they can be connected endpoint to endpoint, but they're not all one object. So with a P-line, what we're going to find is if we draw a P-line, what happens when we draw that P-line, this guy is all one object. And it can actually have arcs incorporated into it as well. So this could be one unique critter. With a line option, you have these guys here that are called endpoints. With P-lines, these are called vertexes. So what you have is what's called a vertex. And the vertex exists like here, and exists here, and here. And there's a direction associated with this polyline, so it knows whether it's going, like, say, either that way or this way. So it's a very complex kind of thing. We've actually taken a look at a command that is a polyline, and that would be the rectangle. Okay, so we talked about that last week. So here's what I'd like you to do, and you can follow along. If you would draw a couple of lines for me, I'm just going to eyeball a couple of lines in here, like that. Then when you get done, go ahead and hit the Enter key. So if we notice this is what we've got as a 3-segment lines. If we come over here to the polyline command, essentially we're going to do the same thing. Just pick 1, 2, 3, 4, and then hit Enter. So you'll notice as you look on the screen, you really can't tell the difference between these two objects. Although if you come up here and click, let's say, on the line segment, you'll notice just that line highlights. And if I click on the polyline, you'll notice that the whole thing highlights. And that's one way you can tell when you have a polyline versus a line. Also, if you will notice, these guys are called grips. The grip in the center here is different than the grip there, so that kind of shows you it's a little bit of a different type of object. Okay, so the polyline, it's one unique object as opposed to separate ones. Now last week I showed you can take a polyline and you can explode it, so you can convert a polyline into this type of object. And next week we'll probably talk about, or maybe a couple weeks, we will talk about a way to take 3-line segments such as this and convert them into this. So you can kind of go both ways, okay? So if you've got those selected, just go ahead and delete them, and I'm going to go ahead and select these guys and delete those as well, okay? So the polyline has sub-options. Let's go ahead and we'll click on that polyline and just pick a point anywhere, because to actually see your sub-options, you need to actually start a first segment. So you notice at the bottom, you can have arc, what they call half width, length, undo, and width. So we've noticed when we were working with the rectangle last week, we talked about width, and width and half width are essentially the same thing. It's just difference in the way they're speccing it. So if we go and look at what we're talking about here, I need to do this here. Hold on a sec. If I look at what we're talking about here with width, when I have a polyline that I have drawn, the polyline, if you're giving it width, what it's going to do is it's going to give it width. It pulls it out like in that direction, okay? And the width is actually, would be spec'd out like that. So that would be our width option. The half width would be the distance this way. So that would be half of your width. And as we talked about last week, the vertex is embedded right in the center. So there is no way to make this like 0.1 and 0.3. So it has to always be equidistant, okay? And it's pulling that out in the XY plane. So it just always will work that way. Okay, so let's go back here. So if we give a polyline width, one of the things you can do with a true polyline as opposed to a rectangle, when you do a rectangle, you have a constant width. When you do a true polyline, you can give it a tapered width. So it's going to ask you for a starting width and an ending width. So if you're still in the polyline command, you might want to just go ahead and hit the escape key to cancel it out, and we'll start that over. Okay, so I'm going to go to the polyline. I'm going to pick a point. And then again, I have the option of half width or width. I'm going to just choose width. And what we're going to do is notice it's asking you to specify a starting width. So it's got a default of value of 0 right now. So let's give it, don't make it too big. I'm going to make mine 0.25. And then it will ask me for an ending width. And notice your ending width is also 0.25. That's by default. If I wanted to change that, I could, but I'm going to accept that. So just hit enter. And so now you notice as you draw a polyline, you have this kind of thing going on like that. And as you keep drawing, notice that it looks really nasty up here. It's not closed there, and it's not closed there. But when you exit out of the polyline, hit enter, you'll notice what it does is it fixes those vertexes. So it fixes that vertex, and it fixed that, and it fixed that. Okay? Is everybody kind of seeing how that works? Anybody a question about that? We're all okay?
Yeah.
So if you would click on your polyline, you will notice that, and we saw this with the rectangle last week, but you'll notice that this is embedded right in the center there. That one is embedded right in the center. So that's how that works. And the edge of the polyline really doesn't exist, okay? It's just the way it looks, okay? So if you just select it like that, you can hit the escape key. That'll terminate it, okay? So that one's a pretty straightforward process. The other thing that's kind of nasty with a polyline, and you have to remember this too, is that once you set your widths up in the polyline, it remembers them. So if you want to draw another polyline and you don't want the width on there, what you need to do is set that width up. Otherwise, it's going to continue using the same width. Okay, so you have to just watch that. Okay. So we're going to go ahead and we can just delete this guy out. And I want to show you another option that's in there. Go ahead and select it and then just hit your delete key. That works very well. So the other option we want to look at is called a close. So a polyline thinks it's either open or closed based on how you draw it. So if we look at, for instance, if I go over here, what I'm saying is if I start at a point and I come to another point and I draw it back like this, that looks like a closed polygon, but it may not be depending on how you draw it in AutoCAD. And I'll show you the difference here. And particularly when you have width on, you can tell that. So we're going to leave that width in place. So we're going to go back over here. And what we're going to do here, what I'd like you to do is just go ahead and delete your screen. You can type in, if you've got a bunch of stuff on there, what you might want to do is just type in E, enter, and then all, and do that enter twice. That'll clear it. And the other thing is to fill your screen. We're going to go and do a zoom all. So just type in Z, enter, A, enter, and that will fix your screen. So we're going to draw two polylines. One that we're going to call an open polyline, and the other one's going to be closed, and I want you to notice the difference, okay? So we're going to go over here and do a polyline, and I would like you to start that first point at a specified coordinate of 2, 2. So we're going to enter 2, 2 and hit enter. Notice where it comes in, and then just pick a point, pick another point, and then we're going to go back to 2, 2. So we're just going to type in 2, 2, and then hit enter. And then when you're done, hit enter again, okay? So what you'll notice about this polyline is that it's beveled shut here, it's beveled shut here, but notice it's not beveled shut here. And the reason it's showing you is that this polyline thinks that it's open, even though we technically or physically went from a starting coordinate to the same starting coordinate. So if we close it truly, we have to use the close option that is built into the polyline. So if you come into the polyline command, just pick a point anywhere, pick a second point, pick a third point, and then notice down here now there is an option called close. You just select close, and you'll notice it closed the polyline, and it thinks that this polyline is actually truly closed. And you can notice the difference. This one's closed. This one technically is what you call an open polyline. And you can't tell that unless you have width on it. For most applications, that would not do anything for you. It wouldn't be a big deal, but it's just something that's nice to know that you can deal with that, okay? Everybody see that? I hope. Okay. So notice there's some other options here, and the other option here is called length. So we're going to take a look at length. So what we're going to do is go into the polyline command, pick a point, and pick a second point. So now, if I want to continue this segment going in the same direction, but I don't know that coordinate to get me in the same direction, but if I do know the distance, I can just type the distance in and use that length option. So if I go into the length option here, it asks me to specify a length. So if I type in a value of, let's say maybe 5 and hit enter, what it did was it continued this guy along that point at the same angle. So I didn't have to specify the angle. All I needed to do was specify the distance. And if you enter a positive distance, it goes in this direction. If you enter a negative distance, it would have gone in this direction. So it would have put a polyline on top of itself, okay? So if you hit the escape key, that'll terminate it. So it looks like we have a single continuous line here. But the reality is if you click on this polyline, you'll notice it actually attached another segment. So from that grip to that grip was the first segment. And then from this grip to that grip is a segment that it attached to it. So if I would explode this polyline right now, I would come back with 2 line segments, not 1, okay? Now, a little bit later on, we're going to talk about a command called lengthen, which kind of does the same thing, but instead of actually attaching a segment, it would just push this guy up. So there's a bit of a difference, okay, between the length option in the polyline and the lengthen command, which we'll get to later. Is everybody okay with that so far? Any questions? Okay. All right. So if you would, go ahead and delete your objects that are on there for me. I'm just going to hit erase all and enter twice, and that'll take it out. So we also have an arc object that we can attach to this. So let's go to the polyline command, pick a point, and notice then once you pick a first point, there's an arc option that pops up. So you really have, in the polyline command, you have what's called a polyline and a polyarc, okay? You always start out in the polyline option. So if we pick another point, for instance, let's just go ahead and pick a point. Now we go to the arc option. You'll notice that the menu changes totally, the sub options, because all of these are talking about arc options, just like the arc command we talked about up here. So for instance, we have angle, center, direction, radius, and second point. Those are all sub options of this arc. So right now it's kind of looking for my endpoint. So if I pick an endpoint, I can pick another endpoint, I can pick another endpoint. What you guys should notice about this is all of these arcs are tangent. Okay, they're all tangent. And that's kind of neat, but probably not going to be an option that you're going to be using too much. If you want to go back to the line, notice there's a line option, so I can go back to line, okay? And if I want to make a tangent line, what I can do, the little trick is I can go to lengthen, and then I can just give it a distance, and it'll shoot that out tangent. Otherwise, if you don't do that, it's going to give you a non-tangent line to that arc, okay? So I can go back and forth, arc and line, and ultimately close it, okay? So polylines are kind of cool because they can be very, very complex critters, and then of course we can explode them and whatever. We don't use them as much as we used to. They just don't have as much of a use as they did at one time. So I want to show you one other thing that's really cool about polylines. Just go ahead and click on this, and we'll just hit the delete key. So another thing that's really neat about this is tapering a polyline. And this is kind of cool because it's not, you can't really do this with any other object. So what we're going to do is we're going to go into the polyline command, and we're going to specify a point. And we're going to change the width up a little bit. So what I'm going to do is change that width. I'm going to make my width 0.75 and my ending width 0.75. So I got a pretty good width going on here. So I'm going to attach a line. Then I'm going to go into the arc command. And what I'm going to want to do is taper this arc. So what I'm going to do is I'm going to give it a width. Starting width is going to be 0.75 again. But I'm going to make the ending width 0. So notice as I taper this guy out and hit enter, what's happening, I went from a 0.75 width to a 0 width. So this isn't a concept of tapering. And again, this is the only type of object you can do that with. Okay, so that's kind of a unique thing. Any questions on that? Anybody? Anybody see anything or think of anything they want to talk about? All right, so one thing about a polyline, if you aren't looking straight down on it like I am here and it has width, it's not going to look like it's filled in. So I'm going to just move this just a little bit. There you go. Whoop. Trying anyway. Let me do it a little bit differently. I'm going to move that just a hair out. So you notice this polyline looks like this now. So if you ever see this on a polyline, typically what that means is that you're not looking top down, okay? If I do change that to a top down view, notice it fixes it. So another way that you can control that look to your polyline, okay? This thing has what's called a fill associated with it. So what we're going to do is come down here to the command line and we're going to type in the word fill. Just type in fill, F-I-L-L, and hit enter. And notice your fill mode has two options. Either it's on or it's off. So right now my polyline is considered on as its fill. If you turn your polylines off, notice there's no change, but you have to force what's called a regeneration, which we'll be talking about here later. So you just type in RE for regen and hit enter. There you go. And it should look like that. And it'll stay looking like that until you change that back. And here's the other thing to know also. AutoCAD plotting is what they call WYSIWYG. So that stands for what you see is what you get. So if it looks like this, on the screen, it's going to look like that on the paper that you plot it to, okay? And fills will govern other things too, by the way, so not just polylines. So you have to be aware of that. So what I want everybody to do, let's go back into the fill command, because once you turn this thing off, it stays off. So we're going to set our fill back on, type in the word fill, set your on setting back, and then you're going to type in RE for regeneration and then hit enter, and that should be back, okay? Is everybody getting that to work all right?
Yes.
All right. So we're going to go take a look at the next command. It's called a polygon, and the polygon is actually located right behind the rectangle command. So if you open this up, you'll notice there's your polygon command, okay? So there are 3 sub options for this guy. Let's go over, we're going to drop over here a minute and let me swap out of here. You can either create a polygon with what's called a center point and an inscribed, or a center point circumscribed, or what they call edge mode. So I'm going to show you what we mean by the 3 differences. So when you do a polygon, there's a circle that's associated with it. It's actually an imaginary circle. You won't see that circle. But when you define a polygon, you have an imaginary circle. So the first thing you do is you select where your center point is, which would be approximately like, say, right here. Then it's going to want to know your radius. So if this guy is circumscribed, or inscribed rather, by in a circle, or circumscribed about, the polygon is going to be inside of this thing like this. And it's going to define a radius that goes from here to that vertex. So this guy's inscribed inside a circle. If you have the other option is circumscribed. Oops. Let me try to get a circle here. So the other option, this is a little bit harder to draw. It's hard to draw, but this one, the polygon exists. Whoops. I'm going to do that. This one exists outside of the circle. So what it does is it surrounds the circle like this. Okay. And the radius for this one is going from there to the midpoint. So there's a radius function here, and there's a radius function here. In both of these cases, you don't actually see the circle. The circle is not a real function. The other type of polygon they have is, let's see, they have, like, it would just be 1, 2, 3, like that. So you can define then what's called the edge option. So you would have a start point and an end point, and what you're defining is this distance, like that. The other thing I need to mention, and I'm not drawing these very good, but these polygons are called regular polygons. So a regular polygon means that this distance, and this distance is all going to be equal, and the angles that you would have, that angle and that angle internal and that angle, they're all the same. Okay, so that's what we get when we get a regular polygon. The other thing about polygons is they are 2D closed p-lines. Okay, so you're actually generating a 2-dimensional closed p-line. So if you have your screen set up like I do here, let's go ahead and we are going to just erase everything. So just type in erase and then the word all, and then hit enter twice. And you might want to do a zoom, enter, all, enter, just to get everything out. All right, so when we go to the polygon command, it's right here. So notice it right away wants to know number of sides, okay? So minimum number of sides you can have on a polygon is 3. Okay, that's your minimum. Anybody know the maximum number of sides on a polygon? Anybody take a guess?
Isn't it 12?
No, it's actually way more than 12. Okay, we can have a polygon way more than that. Theoretically, it's infinity. Okay, but if you have an infinite number of sides on a polygon, you're going to get a circle or approach a circle. So AutoCAD does have a maximum, and the maximum number of sides in AutoCAD is 1024. And that number is actually a binary number. That's 2 to the 10th power, okay? So what we're going to do is take a look at, let's give this side, let's give it 10. So we're going to come down here and do 10 sides, okay? So once you tell it the number of sides, it's going to want to know a center point. And if you do a center point, then you're going to either do a inscribed or a circumscribed option. And if you don't want that, then you can do an edge. So what we're going to do is let's just come and pick a point anywhere. And notice you have this option called inscribed in a circle or circumscribed about a circle. And the default is I, inscribed. So we're just going to go ahead and hit enter, which means it's inscribed. So notice as you pull this out, you don't see the circle. But what you're doing is you're seeing the radius from the center point to that vertex. So the circle is on the outside of this. And all those little vertexes are just hitting a value there. So you can specify a radius by just dragging it out. Or you can actually come down here and type a value. So let's type a value. Don't make it too big. Let's make it, let's say, maybe 5. Okay, mine was a little big. So there's my 5 radius polygon. And again, if we measured this, you would see that distance across, that distance, those would all be the same distances, and all these angles were the same because it's a regular polygon. If you click on this guy, you'll notice he's all one object, okay? And if you type the word list, L-I-S-T, and hit enter, you'll notice it doesn't tell you it's a polygon. It tells you it's a lightweight polyline, okay? And what you're looking at is, this is the vertex listing. Also notice, which is kind of cool, says it's closed, because we know it's closed, and there's, it calculates an area for you, and it calculates a perimeter. So that's also pretty interesting, the way that works, okay? So we're going to contrast that with another polygon here. We're going to go polygon. And notice since we had just created one with 10 sides, it's going to remember that number for me, okay? So I'm going to just accept that by hitting enter. And I'm going to specify another point, but this time we're going to do it as a circumscribed. So notice as you drag this out now, this is circumscribed about a circle. So the circle, the imaginary circle, is actually inside of the polygon. And the radius that you're speccing out, is actually the radius from the center to the midpoint of the line segment. So let's use 5 again. Just type in 5 and hit enter. And you should notice that one of those is slightly different than the other. I'm going to move this guy inside it so you can see, if you notice, the one is slightly bigger than the other, okay? Because geometrically, the way they're defined is different, okay? But they would actually have the same angles, okay? Sides increased on the one versus the other, but the angles are the same, okay? So also notice there's no center point grip on this thing. So it used to be kind of hard to find the center point of a polygon, but there's a way to do that now, okay? Is everybody getting that to work?
Yes.
Because there's a polyline, or because these are polylines, there would be a way to give these width later on. So you could actually edit the width into these, okay? And of course, you could also take a polyline, or this guy, and explode it if you wanted to. All right, so let's take a look at the third option. This option is called the edge option. So this option doesn't use a center point to define it. it wants to know what this length is going to be. Okay, so that's a different option. So we're going to go here, and we're going to choose polygon. Let's knock this down to a three-sided figure. So we're going to say 3 sides this time. And instead of choosing the center point option, I actually want to choose edge. Okay. So it wants me to pick a starting point for my edge. So I'm just going to pick that right here. And notice that's like sticking a pin at that point. So you're just pulling it out. And you can change both its angle and its distance. So for instance, let's say we wanted to make this thing 30 degrees with respect to X and a distance of 2 units. So each line segment is going to be 2 units long. So what I could do at this point is type in at, because I want to be relative to that starting point. And the distance would be 2, and then we would say less than 30. So I'm using a polar coordinate type of thing to establish this. And I would go ahead and type that in. And notice if I measured this angle with respect to X, that's 30. And measuring each one of these distance points around here, it'll tell me it's 2 units. So if I go in a command called distance and select that point to that point, notice it tells me that that's 2 units big. And do the same thing if I did that down here. From that point to that point, it's 2 units. And notice also the angle is 30. Okay. So 2 different options, or 3 actually. Center point, inscribed, center point, circumscribed, and then we have the edge option. Okay. Any questions anybody might have at this point? We're okay? You're probably not going to use polygons all that much. I can't think of a good example of them. I mean, I use them occasionally. I can just tell you that. So it's not one that you see a bunch. Okay. So we're going to take a look at this guy called a point now. And the point, that's also one of these little objects that you're not going to use too much. Let's go over here and take a look at it a minute. The point command really is just a little 2D critter that gives you the ability to draw an object that might look like this. This is a point. That's a very simple point, something like that. It could look like an X. It can look like you can have a circle with an X through it. Okay. These things cannot be deconstructed. So in other words, I can't blow this apart and get a circle in 2 lines, or I can't blow this apart. So, once you have them, that's what they are. The other thing about them is that there are 2 settings that govern these guys. One is called the PD, it's called the PD mode setting. And PD modes govern whether it looks like this, or it looks like this, or it looks like this. And they're kind of weird the way they're numbered. They're numbered 0, 1, 2, 3, 4, and then they go 32, 33, 34, and I'll show you how this works. And then the other thing is called a PD size on a point. Whoops. PD size. And this governs the size of the point. And so basically that's the distance from here to here. And you have 2 settings that you can use for that size. One is an absolute value. So if you say this is exactly 2 units big, it'll always be 2 units. And that, if you zoom in, it's going to look like it gets bigger. And if you zoom out, it won't. It'll look like it gets smaller. You can also set this to a relative to the zoom scale. So when you zoom in and out, and you regen it, the points are always going to look like they're the same size, no matter whether you zoomed in or you zoomed out. Okay. So I'm going to show you how we set these guys up. You can actually type this command in, and you can type this command in, or you can go to this command called dd ptype. And what that will do is allow you to get to a dialog box to do this. Okay, so we're gonna do that first. So we're gonna go back to AutoCAD here. I'm gonna go just clean my screen up real quick. I'm gonna go erase, all. Okay, we get that out. All right, so under format, if you go, let's see, you guys might not have format. So I'll tell you what we'll do. I just want you, I'm going to have you just type in the word DDP type. DDP type. They've actually changed the name of this command, but this one will work. It should pop up this dialog box that's called point style. Okay. So again, DDP type. So what we're looking at here, these guys are your PD mode settings. And this is 0, 1, 2, 3, 4. And then it goes 32, 33, 34, 35, 36, 64, 65, whatever. Ultimately, this is 96, 97, 98, 99, 100. Those are weird numbers the way those work, but they all have to do with a binary way that it sets it up. So that's just how that works. This is your PD size setting, and notice it's set to 5% of the current screen. If you want to make that in a relative unit, or absolute unit rather, you would set this radio button. And what we're going to do is not make it too big. So we're going to set that down to absolute units. Let's make it we'll make it 0.25, okay? And let's choose this PD mode right here, which is actually 0, 1, 2, okay? So we're going to go to point style 2, PD mode, PD size of 0.25, and go ahead and hit OK. So why that is so important is that when you do that, you'll see that when you set that up, points are going to be governed by those settings. So whatever those current settings are set to, that's how that's going to work, okay? So we find the point command under the draw. It's kind of held right here under the draw drop down. And what they have is this command right here, which is called multiple points. They also have an option here, which is called divide, and this one is called measure. I'll show you how to work those. Those are kind of cool too. So, but if we go to a multiple point, notice it just asks you to specify a point location. So if you just pick a point, you pick another point, you pick another point, notice all you're doing is placing points, okay? If you type in the word point, it will only let you do one point and then it'll knock you out. So the difference is that this will let you establish multiple points, okay? So these guys are just little markers, essentially is what they are. And when you're done, you can just hit the escape key and you'll see that. Notice if we zoom in, they get bigger. If we zoom out, they get smaller because the setting is set such that it'll do that. If you have it relative to the screen, it'll be different, okay? So we're going to go back to DDP type, or yeah, DDP type, and hit enter. And what we're going to do is change the look of the point. So if we click that guy right there and hit OK, you should notice that all the points in your drawing went to the same look. So it's impossible to have different points within the same drawing. And unfortunately, I don't like that aspect because I can use these as little symbols that mean like fire hydrants or trees or whatever. And because they all look the same, that's not very useful for me, okay? So let's show you how the divide works. This is a really cool little tool. So just take and draw a little line, right, let's say that big, okay? And what we're gonna do is divide this line. Now, it doesn't truly divide it. What it will do is it'll place a point marker where the 1/4 divisions are. Okay, so we're going to go to this command right here, which is divide. And it wants you to first select the object. So I just come down here, select the object, and then it wants to know the number of equal segments. So I'm going to say I want 4 segments. So notice it divided it into fourths. So that point, and that would be the 1/4, that would be the 1/2, that would be the 3/4, and that's the end point. Notice that line really isn't divided, okay? But it does put a little marker that then you would have the ability to snap to. So these little guys are not going to be too useful. There might be an occasion where we would use a point. I'm not sure I'm going to even have you guys do any drawings and have those this semester, but that's a possibility. Okay. All right. So the last one we're going to take a look at from a object command today is the donut. And the donut is also a 2D polyline. So let's go take a look at that here. So the donut, like its name implies, will draw a donut. What it actually does is it takes and it draws an arc. I don't know if I can draw an arc with this guy or not. Nah, I'm not going to be able to get it. Well, anyway, well, I guess I could do that. If we envision, what you get is a donut, and you're going to have another one on the inside. Those would be centered, but what it's going to do is fill it in from one side to the other. Okay. I think it looks personally more like a washer than it does a donut. So expect with this, they're going to ask you where the center point of this donut is. And they also want to know what this distance is and this distance, which we define this as the outside diameter. So this is called your outside diameter. And this is called your inside diameter. Okay? And your outside diameter has to be greater than your inside diameter. Now you can set the inside diameter equal to 0, and that'll do something pretty cool. Okay, so we'll take a look at this. The way it draws up this polyline is it draws an arc that's 180 here, and then it connects another 180-degree arc here, and then it gives them width. So when you explode this thing, what you get back from it are two actual just arcs. Okay, so we're going to go over back to here. I'm going to just delete what I got here, erase all, and we're going to look at the donut. The donut is also located down here, right there. They do spell it D-O-N-U-T, so that's not a misspelling, that's how they spell it. And D-O, I believe, is the alias if you're typing it. So we would just select that. And notice it's going to ask you to specify an inside diameter. There is a default value in there. So if you want to accept the 0.5, you can. Go ahead and hit enter. And then the outside diameter, notice, is twice as big. So all you're going to do here is you just pick a point, and you pick a point. And so wherever you pick points, you just get these donuts. And that's kind of where it is. Okay. So again, that's not an object that you're going to use too much. It does have some value, but a lot of times it's just one that you won't use too much. Now, what I use it for is to create filled circles, and you're going to be using this on Lab 2 as well. But if you take and set your inside diameter to 0 and your outside diameter to greater than 0, you'll get a filled circle. So we're going to go on and do the same thing. Donut. For the inside diameter, instead of having it a value, let's make it set to 0. Make your outside diameter 1. And go ahead and now, if you place donut, you'll notice what you're getting is a filled circle. So that, to me, that's very useful. Okay, I use this option more than I use this option, right? And at one time in AutoCAD, there really wasn't any other way to do this. So now there are other ways to fill circles, but this is still a convenient thing to know how to use. Take and do this too. If you would click on, let's say, that polyline and that polyline, and then go ahead and hit the X key on your keyboard and hit enter, you'll notice you exploded those circles, or those donuts, and this became an arc, and that one did too. Okay, so that's what you get. Also, let's do this. We're going to go back into the fill command real quick. So we're going to type in fill, F-I-L-L, hit enter. We are going to turn the fills off, and then we're going to regen it, RE, and hit enter. And you'll notice that's what a non-filled donut looks like. So again, if you wanted that look for some reason, you could do it, and you can plot it, because what you see when you plot is what you get. Okay? Any questions on any of that? Those are all the objects that we're going to take a look at today. And we're going to take a look at now some utility commands. No questions? Anybody? All right. Going to take that as no. I'm going to go back, and what I want you to do is type in the fill command. We're going to set that in, because remember, if you turn this off, it stays off, and you don't really want that off unless you, for some reason, want it. So I'm going to set my fill. I'm going to turn my fills back on, and I'm going to regen it. So just make sure it comes back and it looks like that for you. Okay? So what we've just taken a look at was the P-line, the polygon, the point, and the donut. So what we're ready to do is look at the commands new, open, and save. Okay, so we've got the new command and the open command, and then we have several different save commands. Okay, so let's go look at those. So when it comes to drawing a new drawing, or any of these commands, they're really easily located. This is new right here. This is open. This is save, and this is save as. So we can find those up here, and this is called your quick access toolbar. Your application menu also has those same commands: new, open, save, and save as. Okay. So let's take a look at new. When you go to a new drawing, really, you can just, if you really simply want to get to a new drawing, you can just click that guy, and it opens up a new drawing for you. That's the simplest, easiest way to do it. But if you go up to here and hit this new, what it will do is it'll pop down a dialog box. And at this point, that dialog box is going to let you create it with what's called a template file. So the default template file is called the ACAD DWT. And DWT just stands for template. It really is nothing more than a normal DWG drawing, but it's spec'd out as a template file. So you don't normally write to a template file. But what they have is, if you work for a company that's got like title blocks and text styles and all that kind of stuff that they always want you to use, you can create all that stuff and create a template and then have that be the one that you use. So for instance, if you go to, let's say, go to the bottom of this list, you'll notice there's one there called Tutorial Manufacturer. So if you click on that, what this is going to do when we open it, you'll notice you now have opened up a drawing, and it's got a title block in it. You're actually in paper space. If you open up this guy, you'll see there's a whole group of layers and colors and those kind of things that are set up for you. So what this does is allows a person to be productive right off the bat once they get started. Okay, so that's kind of a neat thing. Go ahead and close that drawing if you open one like that. Let's go back to new. I want to make sure what you just did was set that as your current template. So what you really need to do is make sure that you come back up here and set that to the ACAD DWT. Okay. Otherwise, every time you open your drawing, it's going to open it up with all that other stuff. Okay. So you can literally take any drawing that you've created in AutoCAD and save it as a DWT, a template file, and make that the file that you open it up with. So it's what we would call a productivity tool, a way to be real productive. Okay, so I'm going to go ahead and close these guys here. So the next option is open. So we would go here to open, we would go here to open, or you could just type in the word open. So click on one of those icons and you'll get this box that pops up. So if you've already had a work in progress, like you've worked on lab 1 and you want to open it back up, open is your option. that you would use. What it's going to want to know is where you're looking, okay? So I'm looking either, in this case, I got this thing called diagrams, but I could open this up and I could say, oh, well, I actually want to be out on, let's say, the desktop. So if I have it out on the desktop, I would go to the desktop and I could find whatever file I'm looking for. So there's a couple in there. That, for instance, there's one I could look at. That's a file. So once you've found a file, then you can tell it how to open that file. So over here, notice there's this group called open, and this has a drop down. So you can open it in one of four ways. You can open it up completely, or you can open it up in what we call a read only. So the difference between these two is that you can completely, fully edit an opened file. You can also completely edit an opened read-only file, but when you try to save any changes to that file, it won't let you. So what you'll need to do is do a save as. So what this does, this keeps you from overwriting a file if you open it as a read-only. And by the way, I'm going to tell you this, sometimes you guys inadvertently will open files as read-onlys. So if that happens and you've made changes, which you can make changes to it, when you go to save, it won't let you. So you'll have to do a save as. If you have a really, really large file, you can do a partial open. So basically, you're just opening a piece of that file. What that does is keeps resources down to a minimum on AutoCAD. Okay, so those are good things. So if I took this file and let's say opened it as a read-only, then I wouldn't be able to save it. So the other thing here is if you go to the drop-down file types, there are several different types you can open. A DWG, a DWS, which is a standards file, a DXF, and a template file. So they're all pretty similar. The one that's the most different here is this guy called a DXF. And that's that stands for Drawing File Interchange Format. So those were created back in the 90s when you had a lot of different CAD vendors out there and they couldn't read each other's files. So the file companies got together, the CAD companies got together and created a common language called DXF. So if I was working in MicroStation, I could save my file as a DXF and then I could open it up in AutoCAD. Okay, so this is still a pretty cool file type to have available. But once you've decided, you know, where you're looking, what your file name is, how you're going to open it, you just hit open and it'll open your file. And this is a pretty complex file, I think. So it's taken a while to, there it is. That's what that file looks like when it's opened up. In fact, this isn't even a real AutoCAD file in that sense, so it's very complex. So it's not working the way I normally see. Okay. So that's how open works. Okay, so I'm gonna go ahead and close this one because it's a good file to open. All right, so the other thing we have are the saves. So what I'd like you to do, just go ahead and open up your lab one. I'm just gonna open up a file. Let me find a file that I've got out there. Go ahead and open up your lab one. Let me see if I can find the file we're working on so we all have the same file. And let me see. Give me a sec to find my file. It's not on the desktop. Okay, come on, cancel. Things don't want to work real easy for me today. Oh yeah, that one works. Okay. So here's like your file one that you guys open. So when you open it, I can save this under different formats. Okay. So if this drawing exists already, I can do a save, and when I do this save right here, it's called a QSave. So when I hit QSave, it automatically just saves right to that drawing. Doesn't ask me any questions of what I want to call it, where I want to take it. Okay. If I come over here, this is save as. Save as will allow me to save this with a new name and in a new location. So if I want to save this file on my desktop, what I can do is take it to the desktop and select that right there. And what you can't see on, well, you might be able to see it. This now should say desktop. Mine's covered by my screen thing there, but it should say desktop or wherever it's located, and then it's that file. And if I went out to my desktop, I would see that sitting there. So save as allows you to save it with a different file name, and it allows you to save it in a new location. Also, if you've never saved a file, okay, so if I'm in a brand new file right here, and I hit this save, the quick save, the Q save, it's automatically going to take me to save as. So you really have no choice at that point, okay? Any questions on that? One other thing with the save as, while we're looking at save as, you can choose to save your drawing to different versions of AutoCAD, okay? Notice at the bottom, this will pop up. So they have 2018, 2013, 2010. So right now, AutoCAD 2021, 2020, 2019, and 2018 are the same file type, okay? But if you wanted to share information with somebody in 2015, this wouldn't work. So what you would have to do is save it to 2013, and then it would allow it to be in that format, and then somebody in a lesser version of AutoCAD would allow them to work with that, okay? If we also notice down here, you can save it as what we call a DXF file. So there's those DXFs, that's that drawing interchange file format. So if you are sharing information with somebody that doesn't have AutoCAD and it doesn't read an AutoCAD file, you can create a DXF file for them, and then they might be able to use that in their CAD system. So those are good things to know how to do. Notice also you can save as a standard file and as a template file. So those are all easy. Okay. So we're going to go ahead and close that. I'm not going to save. Okay. So we'll be utilizing those all semester. And so that was what we were talking about here. The new, the open, the save, and the save as. So we're going to take a look at these guys right here. We got redraw, regen. There's several different zooms we want to take a look at. And then the pan, and then the view. Okay, and then that'll finish this lecture for today, and I will then get you guys started on lab 2. And if there's any questions, then we'll be able to answer those as well. Okay. So let me go back to AutoCAD. So there are 2 ways of kind of drawing cleanup when you talk about AutoCAD. They're called regen and redraw. Let me just go back to here real quick. I'm going to clean this up a minute. So there's kind of like, in AutoCAD, there's kind of like 3 databases that you're working within. Okay, and you can think of this. This is where your CAD file is. This is called a vector database. Oops. Okay, so this is called a vector database. So while you're working in AutoCAD, you are working on things called vectors. And this is what we call a raster database. And your screen, your CRT, your physical screen, is also a raster database. Or data set, I guess I should say. So vectors, when you draw a vector from point A to point B, it looks like a straight line. In raster, what it looks like is stair-steppy. And same thing here. If you've ever looked at your screen up close with a magnifying glass, you'll notice that it really isn't a straight line, it's a bunch of little pixels. So these rasters are pixels, and these are points. that are integers, and this is real world data. So when you're drawing your objects in AutoCAD, they're in this form, and this is your database, but this is what's called the virtual screen. So when AutoCAD wants to display on your physical screen, it has to take the coordinates from here, convert them to rasters, and then convert that from there to physical screen. Okay. So when you go from vector to raster, that's what we call a regeneration, or just regen for short. The command is RE, regen. If you don't have to go back and recalculate your vectors into your virtual screen and then from your virtual screen into your raster, if you can just go grab the coordinates here and then display them, that's what we call a redraw. And that is just R. So here's the thing to think about, and this is the way it's really important. This is the only reason it's important. If you do a regen, it does a complete calculation before it displays. If you do a redraw, it's real quick. So think regen is recalculate, redraw is just refresh. So sometimes when you erase pixels on your screen, certain things of your objects disappear. All you need to do is a redraw. The regen is more important. If you've ever, well, you guys may not have seen that, but in AutoCAD, sometimes when you look at a circle, it doesn't look like a circle. Sometimes if I zoom up on that, it looks more like a polygon. So if you want to force that to look like a polygon, I don't know if I can get it to do it. It never does it when I want it to do it. Get it to happen for me. Yeah, it won't do it. But if it doesn't look right, then what I can do is type in regen, and it'll force that calculation. And back at the very early days of CAD, you didn't want to do regens because it really took a long time. I mean, literally, you would go get a cup of coffee and come back, and it would still be recalculating. The way the processors work and everything today, that's actually not that big of a deal anymore. Okay, so if we wanted to regenerate, we just type in RE and hit enter. If we want to redraw, we just type in R. Right. So that'll kind of take us up into what we call the zooms. So we have quite a few zoom options, and I'm not going to go through all of them. If you guys are in your first drawing, that's fine. I'm going to just go ahead and do the first drawing here. You can find zoom several locations. Under the view section, they have zooms, but it's a lot harder to find some of this stuff. So what I'm going to suggest you use for the zooms is just type in the zoom command. So what I would like you to do is just come in here, and we're going to just type in Z for zoom. Okay. And I want you to notice we have zoom all, zoom center, dynamic, extents, previous, scale, window, object, and what we call zoom real time. And there's another one in there called zoom Vmax. So there's actually a few more in there that we don't see. So two that you want to know right off the bat are the zoom all and the zoom extents. So let's explain those. The zoom all will zoom your limits and your extents, and it puts them together. So if you have limits really on one piece of your screen and extents on another, that can really get you. If you have extents, what it does is it ignores where your limits are set to, and it just looks at the collection of all the objects in your drawing. So in this case, if I do a zoom extents right now, it's just going to give me this picture. So if I zoom out, hit extents, it gives me that picture. If my limits are set coincident with my extents, then when I type a Z enter, A enter, it's also giving me that. So let me show you a case. Let me show you a case where that wouldn't be true. Let me open up that drawing we were looking at before. Yeah, right there. Okay, so I'm going to open this up. So this drawing is a very complex drawing. And I'm going to go ahead and put it into top view. Okay, so let me do it to zoom extents. Whoa. Can't even find it. Okay, that's basically my objects right there. And there's also another object in there right now, so that's impacting this. But if I do a zoom all, notice that thing disappears, and actually it's probably sitting up here somewhere because my limits are probably way down here. So this is a case where that can be a real problem. In a drawing like what you're dealing with here, that shouldn't be an issue, okay? So if you set your limits such that they equal your extents, then a zoom all and a zoom limits would be something different, or the same rather. I'm going to change my limits here. Watch what happens. So I'm going to go into my limits command, and I'm going to set my limits from that corner to that corner. So notice when I do a zoom extents, that's what I get from my extents. When I do a zoom all, what it's looking at is my extents and my limits, okay? So there is a bit of a difference. But to do those, either one of those, you just type in Z enter, A enter for all, or Z enter, E enter for extents, okay? If you have a choice between the two, I would probably do the zoom extents the most. That's probably the best bet, all right? Is everybody seeing the difference between those two and how those work? Anybody questions on that zoom? Or those zoom types? Nobody? Questions? Is everybody trying this to get it to work? Okay. All right. So, so we have other types of zooms here. The other type is called the zoom window. Okay. So with a zoom window, you can always zoom in, but you can't zoom out. And what you're going to do with a zoom window, you're going to pick 2 points, much like that. The size of that window will determine the amount of magnification. So that would be less magnified than, say, that. So if we want to do a zoom window, all we have to do is type in Z and hit enter. Notice there's a window option, but you don't even have to choose it. All you have to do is just go pick a point, pick another point, and it zooms in. Okay? Do it again, Z enter, pick a point, pick another point, and it zooms in. Notice you can only zoom in with this zoom, okay? So if you're trying this with me, you'll notice that I can zoom in, but I can't zoom out. So if I want to zoom out, I would say Z enter, E enter, and I can go back. Now, some of you guys probably have already discovered, and you've used this, that the mouse wheel does the same thing, okay? Zoom in, zoom out, and depending on where the cursor is sitting, okay, that's kind of a zoom in, zoom out. But those are different zooms. Those are called IntelliZooms. Okay, so those are different than the type of zooms we're doing here at the command line. So you really want to have the ability to use all of those options, okay, at the end of the day. You really want to be able to do all of them, okay? Any questions on that? So we're going to Z enter, E enter. That brings it back. Okay, so the other option there is called a zoom scale. So the zoom scale has 3 settings, okay, that you can work with. So you can do what's called a zoom scale. You can do a zoom scale, and that scale can be set to one of several options. So you can give it a value like 1, or well, let's change that. That's not going to be much of a value. Let's say 2. Or you can give it 2x, or you can use what's called 2xp, okay? So these all mean something different in terms of the zoom. So 2 like this is going to be times the current limits. Okay, so this is saying 2 times the limits essentially. This 2x option is the current display. Current display. This 2xp is in for paper space, and right now it's invalid. So we're not going to consider this right now. But when we get into paper space in a couple of weeks, we'll use this. So we can't use this one right now. But these two are valid for us. The limits type of zoom and the current display type of zoom. So let's go here. Back to that drawing. Okay, so we're looking at your drawing 1. We're going to go into the zoom. Just type in Z. Notice there's a scale option. And again, you don't have to type in scale. If you type in 2 here, it automatically knows what you're talking about. So if I type in 2, it's doing a 2 scale times the limits. So notice it zoomed in based on where my limit settings went, okay? Now I changed my limits, so yours might look different than mine. Tell you what, let me set my limits back so they're coincident with the drawing. So I'm going to make my limits equal to that, much like yours would be. So if I do a zoom 2, it zoomed at 2 times the limits. If I try that again, it's not going to make any change because once you're zoomed at 2 times the limits, you're already fixed because limits is a fixed value. If you want to go out the other way, I could say zoom 1, and that would be 1 times the limit. Zoom 0.5, and that's half of the size of the limits, okay? This isn't a very useful zoom typically for me. So let's go ahead and do a zoom extents. What I do like to use is the zoom times the current display. So this is neat because I can say Z enter 2x. So that's half as big as the current display was. Z enter 2x again, Z enter 2x. So I can keep going in and in and in and in or out and out just by using that X option, okay? So you can either use the X, the XP, or just the scale factor. That's the beauty of that. And that's actually, I mean, you may not see that as a useful zoom, but it is actually really pretty useful. So I'll use that one fairly often. Another one that's really neat is this guy called Zoom Object. Zoom Object allows you to select an object or group of objects, and it basically just zooms to those objects. So you could think of like what it's doing is zooming to the extents of the objects you selected. So if we go into the zoom and then we choose object, so it asks you to select objects. So if I select that object right there, it zooms right to it. Now that's a really, really cool, convenient zoom. That's one I like a lot. I'll use that quite often. And you don't have to do much, just select what you want, zooms to it, okay? So let's go back, zoom extents. All right, so another one here that's kind of interesting is this guy called previous. And zoom previous allows you to step backwards in time with your zooms. So as you're zooming in and out, it's remembering all of these zooms in what we call a zoom buffer. So it holds 20 zooms. So all you would do is type in Z enter, P enter, it just zooms previous, Z enter, P enter. You can just keep doing that and it'll take you back through the buffer, okay? To me, it's not a really effective way of doing zooms, okay? Personally, I don't use that too often, but it's there. So if you want to ever use it, it's good. Okay. Any questions? Quite a few zooms. So let's take a look at the virtual screen. So go ahead and do a zoom, Z enter, E enter, and then we're going to look at the virtual screen. And the virtual screen is actually a lot bigger than the screen you see here. So if you type in Z enter Vmax for virtual screen max and hit enter, you'll notice your drawing gets pretty small. So what this says to you is that as long as I zoom within this area right here, I'm not going to force a regen. But if I zoom outside of this, it'll force a regen in my drawing. Okay. If I force a regen, that'll recalculate the virtual screen. So if I type in RE here and then hit enter, it recalculated the virtual screen so that when you do a Z enter Vmax, what it will do is it'll calculate a new Vmax value for me. Vmax. So it keeps getting smaller. Okay, so that's not a zoom you'd ever use, but you can actually see the size of the virtual screen when you look at it that way. Okay. All right, so let's go back to the zoom extents. All right, so one last zoom, and then we're going to take a look at a pan. So we're going to go into zoom. So we have this option called real time. So instead of using these guys, you can use a real time. So if you want a real time zoom, you just hit enter. You're automatically in a real time zoom. So you'll notice your cursor has changed to this magnifying glass. And this is the way this works. If you want to zoom in, you take the magnifying glass to the bottom of the screen, you left click, you drag as while you're holding it, and then you release, okay? So from the bottom to the top is a zoom in. From the top to the bottom is a zoom out, okay? So we're doing this in real time. Real time zoom out, real time zoom in. Left to right does nothing, okay? So it's only top to bottom, bottom to top, okay? Now the other cool thing about the real time is if you right click, you'll notice there's other sub options. So here's a window. Now this window works differently than the other zoom window. Instead of picking 2 points, you pick 1 point, you hold it, you drag, and then you release, okay? So you pick a point, hold it, drag, and release. So that's a zoom, that's a real-time zoom window. Zoom original would take you to the zoom that you started in, and zoom extents does exactly what it says. It'll do a zoom extents. To get out of the real-time zoom, you just hit the escape key. Right? So what's very convenient for zooming is just taking your mouse wheel and zooming it away from you, zooming it in, okay? So rolling it away is a zoom out, or zoom in rather, rolling it towards you is a zoom out. Zoom in, zoom out. Wherever your cursor is, that makes the difference, because notice if I put it right there, it's zooming based on where the cursor is. If I set it over here, it's doing it differently, right? There's also a little trick with the middle mouse is if you double click it real quick, it's kind of hard to do. If you double click it real quick, it's a zoom extents. But you got to get used to it. It's not that easy to do. In fact, I'm not doing it very well. But it will work typically, okay? So that's what we call a zoom IntelliZoom. So the other one we have is what's called a pan. You have a pan on your mouse. If you hold the mouse wheel down, you get that hand. This is panning. And notice what it's doing is it's not changing the magnification. It looks like it's moving the drawing, and it really is, but it's moving the coordinate system with it. So it's actually not moving objects. It's just moving the picture, okay? That's called a pan. If you go into type in the word pan, P-A-N, and hit enter, you're in a real-time pan. Works the same way, except now you just hold the left mouse down. Left mouse, okay? So you can just do it that way. When you're done, you just hit the escape key. All right, so those are two different types of pans. One is the IntelliZoom pan, and the other one is just the pan by typing in the word pan. Either one is considered real-time. All right. So the last command we're going to take a look at, then I'll see if there's any questions, and we will go in and start looking at that second assignment. The last thing we're going to take a look at is what's called a view. And you can think of a view as a saved zoom. So what that allows me to do is if I have a really complex drawing, instead of zooming in and zooming out and zooming in to get to a point, I can save that zoom view, and then it'll allow me to just go right to it. So for instance, we're going to type in the word view, okay? and it'll ask me about views. So right now, there aren't any really preset, well, there's presets, but there's no new views. So we're going to create a new view, and we're going to call this zoom view A. Okay, I'm just going to call it A and hit OK. And it'll ask me if I want to set it current or update layers. So I'm going to go ahead and apply this. So it just saved that. So what I'm going to do is exit out of here. I'm going to now zoom in on this guy. I'm going to go back into my view command. And I'm going to create a new view. We're going to call this zoom B. And I'm going to use the current display. I'm going to hit OK and then apply that. So notice I've saved a zoom A and a zoom B now. And if you want, you could go do another one. I'm going to zoom in right there on my title block. And I'm going to create another view. And we're going to create a new one here for C. Apply it. So if you do a zoom extents now, you can go into the view command. You can pick on zoom C, set it current, apply, and there you have it. So it's kind of a neat thing. It's just a way of saving a zoom. What is also kind of neat about those, you can open up your drawing. When you open it up, you can open it to a zoom, and you can also print to a zoom. So that's probably where it's the most valuable, being able to do those kind of things. Okay, so that is our lecture for today, other than the fact I do want to go over the second assignment. So let me see if anybody has any questions. I'm going to go ahead. I'm going to stop the recording right now.